Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 22 of the November daily LeetCode challenge, and we again have a medium question in front of us. This question is having both the topics actually, the matrix topic that we have seen questions previously also, and again the topic of bit. Okay, bit manipulation is coming back. Okay, you can solve this question without bit manipulation, but let me tell you that if you are solving this using bit manipulation, you are among those top 0.001% who are able to understand the topic and apply the same in the concept. Okay, so we'll see the solution, and let me tell you before starting, my solution is going to be even better than the LeetCode solution. Okay, so be proud of that we are going to see something that even LeetCode doesn't can think of. Okay, so though they have given the hint properly, but still they have not uploaded the solution which is using bit. Okay, so let us begin this question. So it is question 1072, flip columns for maximum number of equal rows. Okay, so I hope when you are seeing this video you already have gone through the question. So what is happening here is, see, basically what they are saying is you can flip any number of columns. Okay, what is the flipping means? Flipping means that when you flip a particular column, all the values in that column will change. So first of all, it's a binary matrix. Okay, binary matrix means what? See, it means either it has zeros and ones. Okay, when you flip a column, what happens? All the numbers present in that particular column will change the bit. Okay, for example, let us see here. So what happens is, let us say I'm going to flip the first column. Okay, in this case, this 0 will turn 1, this 0 will turn 1, and this 1 will turn 0. Okay, that is, they will be changing. Okay, 1 will become 0 and 0 will become 1 if that particular column is flipped. Okay, so that is the basic meaning of flipping. So what they are saying now, see, you can choose any number of columns in the matrix and flip every cell in that column. Okay, this is what is flipping. Okay, so they've explained what the flipping is. I've already explained the same. Return the maximum number of rows that have all values equal after some flipping. So please try to understand. We are going to flip, okay, values of a column. Okay, but they're asking how many rows will become equal after certain number of flipping. Okay, see, here there is no constraint on how many columns we can flip. Okay, you can flip any number of columns. So by now you would have answered one thing at least, that the answer for always this question is always going to be 1 by C, because there is no constraint on how many times you can flip. So that means I can flip in the way I want and always make any one column at least equal. That is, all the elements in one column I can make equal. That is for sure. So the minimum answer is going to be 1. Okay, remember that one thing. So that is the base condition. After that, see, try to understand. They're asking return the minimum number of rows that have all values equal. Remember, they're not saying whether all the values should be 1 or all should be 0. They are saying they should be equal. Okay, so basic idea is that after certain number of flips. So let us try to understand what is happening in this question. Let us see this particular example. See, I guess this is the third example that I'm showing you. Okay, so see here, please pay attention here. This is a very, very interesting question and you will get a lot to learn from here. Okay, so this is the third example that we are having. So please try to see very carefully what exactly is happening. Okay, so the idea here is, whether if I flip this particular column, that is the last column, if I flip, can you quickly tell me what will happen? See, this will become all 1 and this will become all 0. So after flipping the last column, basically two rows are becoming equal. So do you agree with me first of all? Okay, if you are not agreeing, that means you have not understood the question till now. Okay, so the question is, if I flip the last column, what will happen? All the values in that particular column will flip. Okay, that is, this 0 will become 1 and this 1 will become 0 and this 0 will become 1. So idea here is, when this 0 becomes 1, all of them are matching. That is, this particular row will be a part of my answer. Similarly, this particular 1 will become 0. That is, all the values in this row are becoming 0. Then again, this row will be a part of my answer. So my answer will be 2 in this case. Okay, that is the basic idea. Now let us try to understand what is the logic in this. Okay, so see, what is the common between this and this, why both of them are behaving a similar way. So we'll have to understand about a pattern. So here comes the topic of a pattern. What is a pattern? Basically, see, pattern means that if you see, it doesn't matter whether it's 0 or 1. Okay, just try to understand, the first two value has same in this particular row and then the value changes. Similarly, the first two values are same in this particular row and then the third value is different. So that is the pattern which is same among them. Okay, so the idea here is, whichever column follows this pattern will be affected when I change, when I flip the last column. Okay, so we will be, the solution that we are trying to implement will be on this. Okay, so we will finding out how many rows follow a similar pattern, and if a particular pattern is followed by the maximum number of rows, that will be part of my answer. Okay, so I have explained the whole question. This maybe, like, you can stop this video and with this idea you can solve the question if you want, but this is what we are going to do. That is the basic idea. Okay, so basic idea is, this and this basically follows the same pattern. Why? If you see here, see, the first two digits are same and then the third digit is different. Similarly, here first two digits are same and the third is different. So basically, a pattern is followed. That's why when I flip the last column, both of them behave the similar way. That is, both of them ends up having the same element. Okay, so that is why both of them will have the contribute to our answer. That is what is our question, right? Our question is, return the maximum number of rows that have all the values equal after certain number of flips. So idea here is, we will be trying to find out how many columns have the same pattern. See, idea here is, every column has the same pattern. Okay, that means after flipping some certain number of times, they all will become one. That's all the elements in them will become same after certain number of flips, and that will be our answer. Okay, we'll have to find out how many columns, that is what is the maximum number of column that follow a common given pattern. Okay, so let us start to understand what is happening here. So please pay attention here carefully again. These things are very important. If you understand this, you can stop the video here. I'm guaranteeing you can solve this question. Okay, see here now, this particular thing. Okay, this is one of the rows. Okay, try to understand what is happening, how to say like this is, following a pattern, and how to find ways of other rows are following the same pattern. See, try to understand here. If a row is like this and any other row is like this, obviously we'll say they are the same, right? If they are the same, that means they follow the same pattern. That is one idea of it. Okay, now see the other thing, why this and this are again the following the same pattern. See, I've already explained you this. First two elements are same here, and the third element is different. Similarly, in this, the first two elements are same and third element is different. That is the reason why this and this follows the same pattern. Okay, this and this follows the same pattern. Okay, so now the question is, how will we get to know whether the things follow the same pattern or not? So I am going to introduce the option of XOR here. What is XOR? Let us quickly understand that first. XOR, if you remember, that is fine, but just if you don't know, XOR, what happens is, it's a first of all a bitwise operation, and what happens is, if two bits are same, the answer will be 0. If two bits are different, the answer will be 1. Okay, the same logic we are going to use now. See, the idea is very simple. I will be converting, okay, for example, you have certain these things here. What I will do is I will convert them into numbers. Okay, I will convert them into numbers. Okay, then I will do XOR of them. So what should the result of XOR? That is also again important things here. If two pattern follow the same, if two numbers, that is if two rows follows the same pattern, okay, for example this and this, what will be their XOR? I've already noticed that if the bits are same, the answer will be 0. So if you can quickly tell me, if I do a XOR of this and this, okay, I mean the bitwise XOR, what will be the answer? The answer, see, in this case everything is matching. Okay, here everything is same as this. So since all bits are same, for like the corresponding bits in both these numbers are same, what will the XOR result? XOR result will be this. Okay, and can you quickly tell me, if I do a XOR of this and this, what will be the answer look like? The answer will, see here, every bit is opposite. Okay, that is every corresponding bit is opposite of each other in the two. So the XOR result will look like this. Okay, so I can conclude that if I do XOR of two numbers, and if I get these any result among these two, I can say they follow the same pattern. Okay, that is the same logic that I'm going to use now. Okay, I am closing this video here. Basically, this is the solution that I'm going to implement. If you want, you can pause the video here, go and solve it. If you can do that, that will serve my purpose. Okay, I don't have to continue further. But if you want to see the solution further, be with me. I can show you the same thing what I'm doing. Okay, and let me tell you this very frankly, this solution is going to be better than the LeetCode solution. So when you are trying to see this video, please be very proud of yourself that you are going to learn something that is even others were not able to think. Okay, so let us see now what happens here. So I hope this point is very clear to see. I'm not doing the tracing example 1 and 2 because I will be doing that in my code. Okay, so I'm not going explicitly to that. So let us see the code now. Okay, this will be very interesting for you. After that, you can solve any kind of question. Okay, see here in this. So what is happening? Okay, let me zoom out a bit. It is too much zoomed in. Yeah, so what is happening? First of all, I am taking them. Okay, I'm taking the length of these two. Okay, the way they have decided. Okay, see, M is going to be this particular thing and N is going to be this thing. The same thing I'm doing. Okay, so basically the idea here is this particular M will give me M elements. So idea here is, see, this whole thing will act as a single element for me. Okay, what I will do is I will I will, instead of having binary, what I will do is I will take them as the place values and I will find the decimal equivalent of them. Okay, that is I will each zero or each place here basically represents a power of 2, and I will like raise the 2 to that particular power and get a decimal equivalent out of this. That is, at last I'm going to have M values. Okay, M integers. I will show you how it works. So that is what I'm going to. I'm creating nums array. In this nums array, basically I will be storing integer equivalent of each of these. Okay, so in this case, let us say there are 3 rows. Okay, first row, second row, and the third row. First of all, what I will do is each of these row will be converted to integer. Okay, let us see how it works. I will go through each row. You can call it as a row basically. Okay, what I am doing is that I am multiplying with 2 raised to power that particular position's value. Okay, 2 raised to power that particular position's value, and again I'm multiplying that with this number. Why? Remember, if it is 0, that means again whatever with the position value, it is not going to contribute to our answer. If it is 1 only, then it is going to contribute. For that reason, I'm multiplying with this number also. This particular number is basically whether it's 0 or 1. Okay, that is as simple as that. Okay, so first of all, let us see how it works. Then I'm going to append it to our nums and I'm printing. So till this point, I will just show you in my output how it is coming. Okay, so if you see here, this is how it will come basically. This is the example 3. If you see here, this particular number basically corresponds to, okay, let me zoom in. Yeah, this particular number corresponds to the number 0. Okay, the number 0. Similarly, this particular number, if you consider the bits here as the position value, that is the positions, and that trying to find the equivalent decimal equivalent of it, you are going to get 1 here. Okay, as simple as that. For this particular thing, you are going to get 6 here. Okay, that number is 6. Okay, till this part, I hope you are able to understand. Okay, because the next part will be slightly more complex. Okay, till this part, I hope you are understand. Okay, so I'm printing the number for you, and then I'm creating a set. What is a set? Set basically means that here it will use the hashing thing. Okay, see, these are just basic things. These are not something new that I'm introducing here. I've already used them. Just for your sake, I'm explaining here. Okay, I'm going to use a set to understand which all row patterns I've already visited. Okay, this will capture basically the pattern that I've already visited. Okay, that is, if a particular pattern is there in the whole array, I will capture that only once. Okay, it will take only 1 unit of space for a single pattern, as simple as that. Okay, and then I'm declaring a eligible set. What is that? It will tell me the number of eligible values of the XOR result. Okay, in this case, if you see, we have only two eligible values. Okay, the XOR result should be among them for two numbers. Only then we will conclude that those two numbers are following the same pattern. Okay, I've already explained a detailed explanation on this, on why these two numbers are coming. Okay, I don't want to go through that again. So the idea is very simple. If two numbers are exactly same, then obviously they follow the same pattern. And what will the XOR result? XOR result will be 0, because every bit is, and the two numbers are having the same value. That is why you will get a similar result in the XOR. Okay, let us say for this and this. Okay, here what will happen is every bit, okay, in the two numbers are different. Okay, for example, if you see, this bit is totally opposite of this bit. Okay, same like that for every place. Okay, all the three places. That is the reason why you will get all ones in the XOR result. Okay, so these are the only two results that we are going to get. And now, what is the decimal equivalent of this? It is going to be 0. Okay, let me write that also here, because you will not understand the rest. See, the decimal equivalent of this will be 0, and the other one, okay, this, what is the decimal equivalent of this is going to be 7. Okay, what is this? See, let us say there are three places here. Okay, so what I will do, 2 raised to power 3 minus 1. Okay, because we are starting from 0, so I have to do minus 1. Okay, this can be written as 2 double star 3 and a minus 1. Okay, 2 raised to power 3, which is yeah, you can do that. Okay, 2 over 3 is 8, and minus 1 will be 7. So that is what is 7. So I am going to calculate it like this. Okay, in my code also. Okay, let me zoom out again. Yeah, yeah, that is what I'm doing here basically. If you see, yeah, 2 raised to power n minus 1. Okay, so this is one value and the other value is 0. Okay, if the XOR result is between these two, that means yeah, the both the numbers are following the same pattern. Okay, I'm creating a max answer. This will tell me which particular pattern follow is is followed by most numbers in the given matrix. Okay, this is like that. So what I'm doing now, see, I'm not going to use the matrix anymore. Okay, I will be using throughout the nums only. Okay, what is nums? Nums I already shown you in the previous output. It is having the decimal equivalent of all of these. Okay, for each row I have now inserted a decimal equivalent in this. Okay, so what I'm going to do next, I'm setting a for loop. I'm going through each index of this particular, on this nums array, which has the decimal equivalent of all the rows. Okay, if it is already visited, that is, if this pattern is already visited and recognized, do not continue with this. Okay, otherwise continue. So for each row, but basically for each number, I'm starting an answer equal to 1. Okay, then I'm going through all the other numbers from I plus 1 to m. Okay, this is going from 0 to m. Okay, for each I, it will be from the next index till the last element. Okay, so what I'm doing, again the same thing. If this particular thing is already visited, don't continue here. Just go to the next loop. Okay, as simple as that. So what I'm checking that whether the, see, this is the ith index, right? See, this is the ith index. Sorry, just a second. This is the ith index and this is the jth index. Okay, so what I'm trying to do, see here, nums of I XOR nums of j. Okay, what is this checking? Whether the XOR result of these two is in eligible or not. What is eligible? I've already explained this. Okay, it's either is 0 or it is 7 in case of this. Okay, when you have the bits as 3, it is 7. Okay, depending on the input. Okay, see here in this case it will be 7. Okay, in this case, if we talk about, it is 2 raised to power 2 minus 1, which is 3. Okay, something like that. Okay, every time it will be different. So that is the reason why I'm taking. And what is n? Basically, n is going to be the length of a row. Okay, so if you see here, what is n? N is going to be the length of a row. Okay, as simple as that. And we are going to have m numbers in our nums array. Okay, as simple as that. I hope you're understanding this. Yeah. If it is so, what I'm doing answer plus one. See, first of all, a number is a following a pattern of itself. That is why always the answer is starting from one. And as I told in the starting, also remember, to this particular question, the minimum answer is always going to be one. Okay. Why I'm saying that? Okay, just a second. See, the idea here is, by default, because see, there is no constraint how many rows can be, how many columns can be flipped. So I can flip anything and get all ones or all zeros in the first row. Do you agree with me? So answer is always going to be one. That is the minimum answer that we can have. Okay. Remember that. So that is the reason why I'm starting this with 1. Okay, and whenever I find a number which has the same, okay, which has the same pattern as that of mine. How I'm going to know that? I'm going to go to XOR of the two numbers, and if they're in my eligible, the result is going to be in my eligible, then I can conclude that both the numbers having the same pattern. Then I can do a plus one, answer plus one, and I can add that number to my listed. Okay, the idea here is, since a number is already having the same pattern, I need not even explore again. Okay, in the other, when I'm start the other, I need not explain that again. So I'm just capturing the index of that. Okay, always remember this listed. Okay, this listed will only have the indexes. Okay, not the numbers. This will just have the indexes. Okay, so if you see here the constraints, that it is going to be up to 300, so it is going to store up to 300 indices in the worst case. Okay, as simple as that. So yeah, that is done. And then finally, for each number, I'm going to find how many numbers are there, okay, which has the same pattern. Okay, then I will compare. If the number is higher than my previous answers, then I will update it here if it is higher. Okay, and finally I will going to return this. Okay, once this loop complete, that is, once I explore all the numbers which has the same pattern as that of my given number, I will add that number answer to my the visited array. Okay, see where the visited is happening. See, this is where it is happening, and this is where it is happening. Okay, these are two places, and where we are checking whether a number is visited or not. See, this is the where. If it is visited, do not explore it again. If it is visited, do not explore it again. Okay, so, and this is how it works. And finally, I'm getting the maximum answer. So let me quickly run this again and show you. We'll this time go through the all the three example cases to understand that. Okay. Yeah. So coming to the third example case, okay, let us go to the third example first. So yeah, example three, as you can see, these are the numbers given to us. What are the decimal equivalents? 0, 1, and 6. Okay. So this is basically 0, this is basically 1, and this is basically 6. Okay. Now let us start with the number 0. Okay, number 0. So basically 1 has the same bit pattern as that of 0. That is, the number 0 itself has the number equal to it. Okay, so basically the number 0 has no other element which has the same pattern. Okay, so that is what it's trying to convey. Next is 1. Okay, 1 and 6 basically have the same pattern. That's what they're trying to convey. Two numbers have the same bit pattern as that of 1. Okay, what are those numbers? 1 and 6. So in this case the answer is going to be 2. Okay, as simple as that. Okay, let us see the other examples. Okay, in this case, if you see, what are the two numbers? 1 and 2. Okay, so you can see that both the numbers are having the same pattern. Okay, so 2 has the same pattern that of 1. Okay, two of the numbers have the same pattern that of 1. And this is the other case, again the same thing is happening here, but the thing is, none of them have this. That idea here is, none of them follows the same pattern. Okay, each one of them will, all the patterns, that is, each pattern has only one number. So in that case, again the answer is going to remain 1 only. Okay, we can see some big case also like that. Okay, for example, this here, all the numbers are having just a single bit. Okay, so the idea here is, all of them are basically following the same pattern. Okay, 10 of the numbers are following the same pattern, and you have to return 10 as the answer. Okay, this is one of the edge cases in while segmented solution. So yeah, fine, that was all for this video. The If you see the constraints here, no, it is basically 300. Okay, so let us quickly discuss about the space and time complexity of this. Okay, we'll go through each part. First, what I'm doing, I am going through each index in that grid. Okay, basically each index in the matrix to calculate the decimal equivalents of my all rows. Okay, so how much time this is going to take? This is going to take O of m into n. Okay, that is one thing. Next, if you see here, what we are doing, basically we are going through all the numbers. Okay, this, how many numbers are there? There are m numbers. Okay, there are m numbers, and for each number I am going through another loop basically. Okay, so in the worst case, okay, this will may take O of m square, but remember, since m and n are same, okay, m and n are almost comparable. Okay, remember, I'm talking about worst cases. When we are thinking about the worst case, we have to think of the the extreme end. Okay, since m and m are having the same extremes, so this whole for loop can also be considered as O of m into n. Okay, so this whole solution on a whole will have O of m into n only. Okay, and this is, see, the operation that I'm doing here, the checking of this, all of them are constant operations. Okay, they will be done within a constant time. Okay, same thing is here. Okay, the missed part and the addition part. Okay, and they also, okay, as simple as that. And yeah, that is all I can say. The XOR will take its own time. Remember, XOR operation will take time because it's a bitwise operation, so it depends on the number of bits. In this case, how many bits we have? Basically we have n bits, so that is there again. But remember that that will not be done for every case. Okay, so if you see the visited, okay, this particular set, so the idea here is, a particular index will be visited in this only one. Okay, if a particular index is visited, it will not be included again. Okay, so that is the reason what I'm trying to say. So in the worst case, we can say that this whole loop basically will be, in the worst case, O of m into n again. Okay, that is O of m square, which is equivalent to O of m into n. Okay, so this whole solution has O of m into n space, sorry, time complexity. And coming to space complexity, see, what are the spaces that we are going to use? We are going to create a num array which has m number of values. Okay, and again the visited set in the worst case will have m. Okay, in the m, okay, when all the none of the numbers follow the same pattern, in the worst case it will have m again. Okay, and I don't say anything else where it will take space. Okay, so if you see the time complexity, space complexity, it is O of m into n, the time complexity and space complexity O of m. Okay, let me show the same here. Okay, So if we see here, this is the time complexity of element 1, and the space complexity will be O of m. Okay, remember that this even lead code solution is not able to match this particular space complexity. They are even taking O of m into one space complexity to solve the question in the best solution. But I have given you a solution which even takes less space complexity than that. Okay, so that could be advantage here. Okay, yeah, see, everything is comparable. Okay, because this thing I am not including in my space and time complexity, but yeah, it depends on the number. Okay, it depends on the number, and obviously the programming language that you're using to calculate it. Okay, currently I've assumed this to be having a constant uh, time complexity, but yeah, again, this it depends. Okay, I have not checked the how the XOR operation will take, but according to me, it should be a faster operation. But yeah, again, we'll have to compare the for this also. I have not done that because even LeetCode was not doing the same, so I have also not done that. But yeah, you will have to use this also in your space and time complexity. Okay, so yeah, that was all for this video. In this video, what we learned that first of all, this we try to decode the question that we have to find. See, the answer to this question will be how many numbers follow the same pattern and what is the pattern followed by the most of the numbers. Okay, and those numbers are going to be our answer. Okay, the numbers for which follows the common pattern, those numbers are going to be our answer. Okay, as simple as that. Those rows, the number of those rows are going to be our answer. So how we decided to how to get the numbers. Okay, how to compare basically whether two rows follow the same pattern or not. So we discovered this particular thing. Okay, and we decided that if we can convert them to decimal and do XOR, so this should be the result of my XOR. Okay, that is 0 and this thing 2 raised to power n minus 1. Okay, this two things should be our result of XOR. If they are so, then we can conclude that two rows are having the same pattern. So this is what we did, and we calculated which rows have the same pattern, and then the row which has the that is the pattern which has most number of rows, that will be the answer, and we are returning the number of rows that follow the same pattern, the maximum number of rows that follow the same pattern. Okay, that was the question, and I've given a solution which has a better space complexity than the solution given in LeetCode. Okay, as simple as that. Time complexity is same as that of the optimal LeetCode solution, but yeah, the space complexity is much better than the LeetCode solution. So yeah, that was all for today. I hope you like this video. You got something extra to learn from this video. So yeah, that was all for today. Please, if you like my efforts, subscribe to my channel. This really gives a lot of motivation to continue further. Our family has reached around 900 subscribers. We are 100 short of reaching 1000. If you can subscribe, then definitely it will give me a lot of motivation to continue further, and I will be able to reach the number of 1000. So yeah, that was all for today. If you like my efforts, please do subscribe once again. Thanks a lot.